Okay, so it is time to brush up 10th grade statistical theory and probability because we are going to discuss in this sub-segment on few basic concepts of probability, but that will help you understand how the whole trading system on the buy side works in your favor. So first of all, let's look at what is expected gains. So every trade that you make or every investment that you make has a finite probability of ending up as a win or a loss. Okay, it's not known a priori beforehand that what that probability is going to be exactly, but the question is that can there be adequate judgments made about this in future, looking at the data in the past. So if a trade ends up as a win or a loss, looking at the percentage chance of each of that, you can decide what are going to be the expected gains of following that particular trading philosophy. Now, in case of ProfitMonk.com, the chances that a particular trade ends up as a winner or not depends on two parameters. Or maybe I'm oversimplifying it at this point, but I think because there are slightly more than two parameters that make that decision, but I think that is sufficient for the purpose of this chapter. And those two parameters are the target profit for the trade, this one, as well as the target stop loss for the trade. Now remember, we said that for our own trades at ProfitMonk, we never use a stop loss. But how about target profit? So let's look at both of these on the web page directly. Let's go back to our friend account page. So we are back onto the account page, and let's look at these two settings. The first setting is target profit per trade, which is right now set at 125%. The second setting that we are talking about is target stop loss per trade, which is set at 35% right now. So let's keep those settings for now, and let's go back to okay, so we looked at Swing Plus in the previous chapter. Let's look at Milestone Plus. So with these settings, for the most recent 581 trades made, the average US dollar profit per trade, and so is 213, which means that in 581 trades, the total profits that you're sitting on is 581 multiplied by 213 on and this is on, I think, May 1st week. Yeah, this is May 1st week right here. So this is what you get. The win ratio is 43%, which is nothing but 231 divided by 581, and these 231 trades more than 125%. Now keep in mind that the gain of 125% means that if you have invested $100 in a trade, you are getting back $225 at least on that. Okay, so this is your statistics. Now let's see what happens if I change the stop loss from 35% to just 5%. Okay, so I have changed the setting. Let's confirm that I've been able to change it. Yes, it is at 5%. Go back to Milestone Plus. Okay, so win ratio improved by 9% from 43 to 52%, which means more trades than last one made are making the target profits. The average US dollar profit per trade improved drastically as well, from 200 I think it was 220 or $230 to 294, which means at this point your portfolio is looking like 581 multiplied by 294. So with the settings that we discussed, if you change the target profit setting or the stop loss setting, you will change the percentage chance that a trade ends up as a winner or not. Okay, so having that out of the way, let's look at what we promised, which is a little bit of probability, and especially this concept here called as law of large numbers, because this is the most important concept out of all probability theories, especially if you're looking at a statistically large populations. So let's look at this example. We have this six-faced dice throw, and we know that it has 6 faces and it's a fair dice, so probability of all outcomes is 1/6. So what is, if somebody asks you, what is the expected outcome of a throw? Okay, so the expected outcome can be computed like this, and it's written using this terminology. So E stands for expected, and value of throw is the value of throw. So what you get is there is 1/6 probability that the output will be 1, outcome will be 1. There is 1/6 probability that the outcome will be 2. There is another 1/6 probability that outcome will be 3, and so on and so forth. And you can do the math yourself. What you will realize is that this number right here, so let's stick with this equation for now. So this number turns out to be 3.5. So the expected outcome of such an experiment is 3.5, which is nothing but the expected values, all the expected values multiplied by the expected probabilities of each of those values. So that's how you get 3.5 here. So now think about it. If you are this probability wizard and you are asked to create a game in this casino where somebody walks in and it's a very simple game. They throw the dice and they make the amount of money which shows up as the outcome of the roll of the dice. So if the dice is 6, you win $6. If the dice is 5, you win $5, and so on. So how much money would or should a casino charge to ensure that they never lose? Well, it's quite simple. You know the expected value is 3.5. So you will design a game where a person comes and they will have to pay at least $3.5, preferably 10 cents more. So I just picked a number here. So you pay $3.60 to play for every roll of dice. And you know that for a game where your winnings is equal to the outcome of a dice roll, on an average over a large number of games, the expected value of a dice throw is just 3.5. So if you are charging 3.6, which is here, then the house always wins over the long run. Now the long run part is very, very important here, because it might happen that you throw a dice once and you get a 6 and you walk away. Okay, so you paid $3.6, you got back $6, so that's an profit of $2.4, $2.40. But over a long run, if you throw the dice 10 times, 20 times, 100 times, the house always wins. So this, in summary, is the representation of two key concepts that are useful for us. The concept of expected gains, which are represented, let me draw here again, by this formula, and the law of large numbers, because the expected gains and probability, as per probability theories, only manifest themselves over large numbers. Okay, so hope you like that, and we are hitting 10 minutes on this chapter.